contract and relax alternately, promoting the circulation of blood. This function is performed by the atrial and ventricular myocytes, which are called working cells. Because they have no automaticity, the working cells also called non-automatic cells. Some cardiomyocytes are differentiated spatially, have no contractility, but can generate and conduct electrical excitation, so they are called spatial conductive tissue or automatic cells, including SA node, AV junction, bundle heath, left and right branches, and distal Purkinje fiber. How does a working cell form the transmembrane potential? Is it a spike like a neuron and a skeletal muscle? How does the transmembrane potential trigger the contraction? With these questions, let's learn about the transmembrane potential of working cells. Take ventricular myocytes as an example to introduce. The resting potential is about -90 millivolts. Just like neuron and the skeletal muscle, it's mainly performed by potassium efflux. In addition, sodium influx through background sodium channel and the sodium-potassium pumps working also participate in it. We've learned the action potential of skeletal muscles and neurons. The depolarization and the repolarization are very fast, so the action potential is like a spike. The action potential of ventricular myocyte also includes depolarization and repolarization, but the repolarization is long and complicated, so the action potential is divided into 5 phases. Phase 0. Membrane is depolarized from -90 to +30 millivolts in 1 to 2 milliseconds. It's very fast, so the waveform is steep. It's due to a large amount of sodium channel influx through white-gated sodium channel. Depolarization caused by sodium influx can cause more sodium channel to open and accelerate sodium influx. This is positive feedback, also called regenerative sodium influx. So the depolarization is very fast. When the membrane is depolarized to 0, sodium channel is activated and closed. Because the white-gated sodium channel open and close very fast, they are called fast channels. Cells which depolarization is due to the opening of sodium channels are called fast responsive cells. Atrial and ventricular myocytes, neuron and skeletal muscles are fast responsive cells. The fast sodium channels can be blocked by tetrodotoxin. Phase 1 is also called the initial phase of fast repolarization. The membrane repolarizes from +30 millivolts to 0 in 10 milliseconds. It's due to the transient outward current, also called ITO current. The ITO channel is activated when the membrane is depolarized to -30 millivolts. The ions passing it are mainly potassium. The potential changes rapidly in phase 0 and phase 1, showing a sharp wave, so the two paths are also called spike potential. Phase 2. The repolarization stops at 0 for 100 to 150 milliseconds, formed a plateau in the curve. So this phase is also called plateau. In plateau, there are both inward and outward current. The inward current is calcium. The membrane depolarized to negative 40 millivolts. The long-lasting calcium channel was activated, but it did not open until plateau. The outward current is potassium. Potassium efflux through IK and IK1 channel. Long-lasting calcium channel is also called L-type channel. It opens and closes slowly, so called slow channel. It can be blocked by manganese and verapamine. It's also permeable to sodium. Phase 3 is also called the end phase of fast repolarization. The membrane repolarizes from 0 to negative 90 millivolts in about 100 to 150 milliseconds. At the end of plateau, calcium channel is inactivated and closed, but the IK current increases with time, so the membrane repolarizes fast. Phase 4, also known as the resting stage. The potential is stable at negative 90 millivolts, which does not mean the cessation of ion flowing. During depolarization and repolarization, there are sodium, calcium influx, and potassium efflux. So the distribution of ions is destroyed. Sodium-potassium pump, calcium pump, and sodium-calcium exchange work to restore the ion distribution. Sodium-potassium pump and calcium pump belong to primary active transport.